Hello, my dear sweet students. I'm going to give you a little dimensional analysis refresher. And I say refresher because you've all done this before in physical science. So if you're a 10th grader, hopefully you remember just from last year. And if you're in 11th grade, then you might need to put in a little bit more effort. Okay, this is what dimensional analysis is. That's what it looks like. So hopefully that's jogging your memory. So let's get into it. Why do we need to use dimensional analysis? What is it? It's the method that we use to solve conversion problems. And conversion problems look something like this. If a person has a mass of 170 pounds, that's LBS right there, what is the person's mass in kilograms? So in order to solve conversion problems like this, we have to use conversion factors like this. So maybe you don't know, but I know, and eventually you will know, that there are 2.205 pounds in 1 kilogram, right? So we're going to use that conversion factor in order to convert from pounds to kilograms using dimensional analysis, like that. So hopefully this looks familiar to you. If not, you need probably more than a refresher. So remember, what we're looking for is right here, and what we're given is right here. Then we put in our conversion factor, and we get our answer. Whatever we have on top, when we put in this conversion factor, we have to put the same thing on the bottom, because x divided by x, for example, cancels both x's out, right? It's 1. So we cancel out the units when we do this. All right. So again, just to reiterate, what we want is here in yellow. So we were looking for kilograms. How many kilograms is equal to what we're given, which was 170 pounds. And then we use our conversion factor. And I know to put pounds on the bottom because I have pounds right here on the top. So when I do that, pounds and pounds cancels, and I'm left with kilograms on the top. And then what we do is we multiply everything on the top and divide by everything on the bottom. So in your calculator, if you wanted to do this, you would do 170 times 1 divided by 2.205, and that gives you 77. So let's do some practice problems. All right. If you are 16.5 years old, how many minutes old are you? So you can pause the video if you want and try to use dimensional analysis. Do not try to do it your own way. You have to use dimensional analysis. If you have a conversion problem on a test and you don't use dimensional analysis, I don't care if you get the right answer, 0. All right, you must use dimensional analysis. And the reason for the big heavy must there, you will see at the end of the lecture, okay? All right, so using dimensional analysis, solve this conversion problem given the conversion factors that I've given you. And like I said, pause it. And if you paused it, here we go. I'm going to go on. So this is too big. Technical problems. I'm going to scoot them over here. Okay. So if you are 16.5 years old, how many minutes old are you? So what we're going to start with is what we want to find. How old are you? How many minutes old are you? So how many minutes? You don't really have to write minutes old are you. Don't waste your time. How many minutes is equal to 16.5 years? That's what we're given. All right, now we need to use all of these conversion factors, but we're going to use one at a time. Because remember, this can get a little bit complicated. And I gave you an easy one before. That just had one conversion factor that we used. But you remember so much about dimensional analysis that you remember there can be like lots of conversion factors all lined up. So let's start with the one that has years. So which one of these has years? Well, I'm so nice and I gave it to you on top. There it is. 1 year is equal to 365 days. So let's put that in then. So what should go on the bottom? It should be years, because years is on the top. So 1 year, 1y equals 365 days. I like to put them in parentheses so we don't get confused. And then you cancel out years and years. And now the units that you're left with are days. All right. So now we're not in minutes. We're trying to get in minutes here, but here we're in days still. Our units on the right side of the equation are days, so we have to get them to minutes. So we're going to have to use another conversion factor. Here we have 1 day equals 24 hours. So I don't have, if you know how many minutes there are in 1 day, then you go ahead. You can just do the direct conversion from days to minutes, but most people don't know that. So I'm going to do 1 day is equal to 24 hours. Parentheses, days cancels there and there. All right, now we're left with hours, still not in minutes, so we have to do our last conversion. Use our last conversion factor. So we have 1 hour is equal to 60 minutes. Cancel out hours, cancel out hours. Why? That is weird. It's lagging. Sorry. There we go. Okay, so then we multiply by everything on the top and we divide by everything on the bottom. And when we do that, we get 8,672,400, and don't forget to write your units, minutes. All right, 8,672,400 minutes. Okay, so that is how we solve conversion problems like that. Let's do one more, and then you can pause the video and try to solve it, and then come back and look at my answer. So it says, if you spend 50 minutes in chemistry class for 180 days, how many hours of chemistry will you have learned? So go ahead and pause the video and try to solve it. All right, so I didn't give you any conversion factors here. And the reason for that is because I'm not usually going to give you conversion factors. You're going to have them memorized. So for example, this one's pretty easy because we all know minutes and days. We just did a problem with it anyway. But for example, if I ask you something like, how many millimeters are there in 1 kilometer? You're going to need to remember there are 1,000 millimeters in 1 meter, and there are 1,000 meters in 1 kilometer, right? So those things, I'm not going to give you those conversion factors. You're responsible for knowing those. Okay, so let's solve this problem then. Okay, so how many, what are we looking for? How many hours of chemistry will you have learned? So how many hours of chemistry? And the problem here, we could just, actually, let's just start with days. Let's say we say, how many hours of chemistry are we going to learn in 180 days? Okay. All right. So you could probably also do this. You could also do this with starting with minutes, but I think it's easier to start with days. And if you wanted to, before you even start, you could multiply 50 minutes times 180 days to figure out how many total minutes you have if you just want to use one or the other. Okay, so let's do that. Let's do 180 days. So in 1 day, how many minutes of class do we have? We have 50 minutes. So that's our first conversion factor. If it's helpful for you, you can write down everything you know about time that you think you might need in the problem next, like up in the corner or something. So for example, you could write 50 minutes is equal to 180 days. And since we're going to hours, you could say 1 day equals 24 hours. Those are probably the only two that you're going to use. Okay, so if that's helpful for you, you can do that. If not, if you want to just do it in your head, that's fine, but it might be helpful for you to write them down like this if you're not super comfortable with dimensional analysis. Okay, so in 1 day, we have 50 minutes of class. All right, but we still want to get to hours, not minutes. So we need to put minutes on the bottom because it's what's on top up there. So how many minutes are there? Let's see if we can go directly from minutes to hours. Actually, we don't even need days and hours here over here on our conversion. We could just use 60 minutes equal to 1 hour. We could just do that. All right, so we have 60 minutes here, and that's equal to 1 hour. We cancel out minutes and minutes, and we're left in hours. And now we can multiply by everything on the top and divide by everything on the bottom. When you do that, you get 150 hours. That seems right, right? I was checking my answer. It seemed funny for a second, but that's right. Okay, so that's another dimensional analysis problem. So you might be asking or wondering, what does this have to do with chemistry? Why do I need to learn this? Why are we talking about hours in a day and how many years there are and whatever? So this has everything to do with chemistry. And if you ignore this and you don't really try to be successful at dimensional analysis, then you are really going to struggle, because eventually we're going to see problems like these that say you will be able to solve problems like this by the end of the year if you do dimensional analysis and you try really hard and get it down. So, for example, what is the mass in grams of 3.5 times 10 to the 40 atoms of carbon? You're going to be able to figure out the mass of that. If you don't use dimensional analysis, it's going to be really hard. But if you use dimensional analysis, this took me 10 seconds to solve. It's very easy. So you have to go through all the practice and practice and practice so that you can eventually do this. An even better problem is this zinger over here. How many micrograms of water are produced when 3.5 milligrams of oxygen gas combine with 5.9 milligrams of hydrogen gas? And you do look at all this beautiful math. Oh my gosh, Miss Montgomery, it's so nice. You will be able to do this, but look, there's no way. Look how many conversion factors there are. There's 5 in that one. It's impossible for you to solve these problems if you do not do dimensional analysis. So maybe you don't like it. Don't care. Too bad. At least I'm not making you do knowns, unknowns, and solve yet. So no complaining, because we love dimensional analysis, because we love chemistry. Say it out loud. I love dimensional analysis. Okay, that's all I got. I miss you. I love you. No whining. Hope you're having a great day. Goodbye.